Hello and welcome to the channel. So in my previous video I got a comment asking me to do a tutorial on how to make snake. And since it's the very first comment that I've gotten on an only invalid video, I thought I'd make it. So for brevity's sake, this will be the simplest version of snake I can think to make. Okay, so here I've created a new Unity 2D project and I've set up my scene. So snake, if you're not familiar, is a genre of game where the player maneuvers a growing line that becomes a primary obstacle to itself. This growing effect is typically done through the consumption of munchies. So keeping that in mind, here's our scene, which is really quite simple. We have 4 sprites and a text object on the canvas. First we have the arena. This is the background for our scene. It will also constrain the snake to the view of our camera. Then we have the snake head, which handles all of our player input, snake movement and the growing effect. Then there's a snake part. So the snake part will follow the snake around, the head of the snake around, and as the snake is growing, new snake parts are created. It will also handle the game over event should the snake head collide with a snake part. Then we have the munchie, which when consumed iterates the score, triggers the snake growth, and the creation of a new munchie. Finally we have the text object, which displays and updates the score, which will be equal to the number of munchies consumed. Let's have a look at our game assets. Okay, so if we go down to the project tab, we can see the snake head, snake part, and munchie are all stored as prefabs. Then we look at the scripts folder, we can see 6 scripts. We have 3 triggers: exit arena trigger, game over trigger, and munchie trigger. Then we have score manager, snake head, and snake part. Okay, then if we go to the assets folder, we can see there's an input actions file. This maps player's input to an action. An action doesn't actually represent a response to an input by itself. Instead, an action informs your code that a certain type of input has occurred. In this case, we're notifying our code whenever a left mouse button has been pressed. In order to create an input actions file, you need to have Unity's new input system package installed. To do that, go to Windows, Package Manager, Unity Registry. Then we scroll down until we find the input system and click Install. So if you're following along at home, Unity may also ask you which input system you want to use. You should either select new or both, although new is the only input system required for this project. You can also select the new input system by going to Edit, Project Settings, Player, Other Settings. Then if you look next to Active Input Handling, there's a drop down, select new or both. Afterwards, Unity will likely want to restart. If you have selected new, you also want to remove the standalone input module from the event system object in your scene. Alright, now we can create our input actions file. Right click in the project window, create, then at the bottom select input actions. Open up the input actions file, create an action map, create an action, set the type to button and set the binding path. In this case I'm using the left mouse button, but you may wish to pick something else. Remember to click save before you close it. Okay, let's look at the direction code. So if I go to snakehead prefab, it has a snakehead script attached. Okay, so whenever we have a left mouse click in our game, we want the snake's direction to move 90 degrees clockwise. So if it's moving left, after one mouse click it'll be moving up, then after each click it'll go from up to right to down, then back to left. Okay, so here I'm including the input system namespace, and within the snakehead class I've defined our directions in an enum. I've also added in a direction member variable. If I scroll down a bit, you can see I've created a method called change direction, which takes in a callback context. Here we're checking if a mouse click has been performed. If so, change the direction. Then, check if the directions variable's value is greater than the last member of the enum. If so, set the direction to left, i.e. if direction is greater than 3, set direction to 0. Okay, so this method needs to be called every time a left mouse click is detected. So if I go back into Unity, attached to the snakehead object is the player input component. Here it is referencing the input actions asset. The default map is set to player, the behavior is set to invoke Unity events, then under events the snakehead object in our scene is being referenced, and the change direction method has been selected. Okay, that's the player input sorted. Let's have a look at moving the snake. So if I go back to the snakehead script, so in snake, the snake's movement is automated and persistent. To do that here, I've created an enumerator function called move. While the game is running, after 0.5 seconds have elapsed, the snakehead moves 0.75 in a given direction. If we move the snakehead a distance greater than its own size, we ensure that the snakehead doesn't overlap with the preceding snake part should the snakehead change direction. To get the direction as a vector 3, I've created a simple function called direction to vector 3. Okay, so the snake is made up of multiple parts. At the start, our snake has 2 parts, the head and the tail. These parts are linked, so when the head part moves, the tail part is always one step behind. So how do we link the head and the tail? We create a linked list. Each part of our snake has a script attached to it called snake part. So if we look at that script now, here we're storing a publicly accessible reference to the next snake part in our snake chain. We're also storing this snake part's previous position. Here we have a public method called update transform, which sets the next snake part's current position to be equal to this snake part's previous position. Going back to the move function, so if all of our snake parts are linked via a reference to the next snake part, then we can access each one by moving through the chain of references. So here, after we've moved the snake head, we get the head of our linked list, and then in the while loop, call its update transform method, which will update the next snake part's current position and then update the snake head's previous position. It then continues down until we reach the end of our snake parts. And just to end this section, if you wanted to store your snake parts in a generic list, here's an idea of how you could update the position and previous position of your snake parts without referencing next. Okay, so now we know how to easily traverse the chain of snake parts. Adding new parts to the end of that chain becomes fairly easy to do. Here, I'm instantiating a new snake part from the snake part prefab. As this new snake part will be added to the end of our chain, we need to make sure its next reference is set to null. Otherwise, the computer would become stuck in the while loop forever. When we're going through the while loop, there's no point checking whether or not the current part is set to null, because if we're in the loop, next will always be an instance of a snake part. So instead, we look at the one after. If that one is null, we insert a newly instantiated part and exit out of the loop. So as you can see, this is the eat method. Now let's look at the script that calls this method. That would be the Munchie Trigger. This is attached to the Munchie prefab. Here I've implemented a trigger enter 2D method. This method is called when the snakehead collider intersects with the Munchie object. Note that this trigger event is only called if both the Munchie and the snakehead have colliders attached, and if the snakehead has a rigid body. Each trigger should also be enabled on the Munchie collider. Here we first check that the object we've collided with is the snakehead. This is probably unnecessary as the snakehead is the only object in the scene to have a rigid body, but just in case we might as well check. Next we trigger the eat method, causing the snake to grow. Now instead of destroying the Munchie and creating a new one, we randomize its position. Here we get a random x and y coordinate based on the arena's width and height. Then we check if the coordinates are intersecting with the snakehead. If it is, we continually generate new coordinates until we find a suitable position. Then assign that position to the Munchie. Notice I've set the Z position to -1 so that the Munchie appears in front of the arena. Okay, let's look at the other triggers in the scene. Here we have the exit arena trigger. This is attached to the arena game object. When the snakehead moves out of the arena, it's teleported to the opposite side. Note that this is an exit trigger event and not an enter trigger event. First, like with the Munchie trigger, we check if the collision object is a snakehead. Then we look at which walls the snakehead has exited from. If it's exited from the left or right walls, we invert our snakehead's position on the x-axis. If it has exited from the top or bottom walls, we invert the snakehead's position on the y-axis. Okay, now here is the game over trigger. So as I said at the top, the snake is the biggest obstacle to itself. So if the snakehead collides with another snake body part, the game over trigger event happens. So the game over trigger script is attached to every snake part object. Again in the script we have the on trigger enter 2D method. We check if the object colliding with the snake part is the snake head. If so, we use the scene manager to restart the game. Make sure you include the scene management namespace at the top. I'm using the scene order in the build as a reference to the scene manager. As I have just one scene, its build index will be 0. You can check your build index number by going to File, Build Settings. There you can also add your scene to your build if it isn't already there. Okay, one last thing before we end. You may have caught that in our eat method in the snakehead class we were referencing the score manager. So the score manager script is attached to the score text. Here we have the score set up as a static publicly accessible property. We also have a reference to our score text, and inside of the setter, whenever the value of our score changes, we have it update our score text. We also have the onDestroy method, which will reset our score whenever the scene is reloaded. Right, that is Snake Remade. Thank you all for watching. Hope this was informative and you enjoyed the video. I enjoyed making it. Tell me in the comments what you want me to make next. Also, if you have any questions about this project, I'll be here. Thanks again. Bye.